Hello everyone and welcome to the video. In this video we shall be discussing about the generation and control of X-rays. That means we will be discussing about the devices of the X-ray generating circuit. So here first we shall discuss about transformers. In this video we will be discussing about transformers, transformer efficiency, transformer losses, construction of transformer, and finally the types of transformers. Now, what is a transformer? A transformer is an electric device which has the ability to convert electrical energy from one coil to another coil. The transformer, it basically works on the principle of mutual induction. It consists of a primary coil and secondary coil which are wound on an iron core. Now here, an alternating voltage will be applied to the primary coil as input, which will produce a changing magnetic flux in the iron core. This changing magnetic flux will produce an alternating EMF in the secondary coil. So transformer means nothing but it is an electrical device which has the ability to convert electrical energy from one coil to another coil by the principle of mutual induction. So the transformer, it has got two coils, primary coil and secondary coil. Now, what are the laws of transformer? The first law of transformer says that the induced EMF in the coil is directly proportional to the number of turns of the coil. That means if NP and NS are the number of turns in the primary and secondary coil respectively, also Vp and Vs are the voltage in the primary and secondary coil respectively, then the voltage across the primary coil will be directly proportional to the number of turns in the primary coil, that is Vp proportional to Np. Again, then the voltage across the secondary coil will be directly proportional to the number of turns in the secondary coil, that is Vs proportional to Ns. Now, combining these two equations, we will get Vp by Vs is equal to Np by Ns. So this is the first law of transformer. That means the induced EMF or the EMF induced in the coil, it will be directly proportional to the number of the turns of the coil. That means the induced EMF will always depend upon the number of turns in the coils. The second law, it is based on the law of conservation of energy. That means the power input in the primary is equal to power output in the secondary coil. That means Vp into Ip will be equal to Vs into Is, where Vp is the voltage across primary coil, Ip is the current across primary coil, Vs is the voltage across secondary coil, and Is is the current across the secondary coil. Now the power input will be always equal to power output based on the law of conservation of energy. Now let's move on to our next topic, that is transformer efficiency. So transformer efficiency is calculated using the ratio between the power output and the power input. So in actual transformers, although we say that the power output will always be equal to power input, practically due to certain power losses, the power input will be always greater than the power output. That means there will be some losses in the resultant power. So the efficiency is the ratio between the power output and the power input. So we can say that the transformer efficiency will always be less than 100%. Okay, that means a transformer cannot be 100% efficiency. There may be certain loss of power due to certain reasons. So we shall discuss what are the reasons that leads to these power losses. So the transformer losses, they can be categorized into three, that is copper loss, eddy current loss, and hysteresis loss. So these are the three power losses that decreases the efficiency of the transformer. So let's discuss the first one, that is copper loss. Copper loss, it is caused due to the resistance of the copper wire. So we know that we are using copper wires in the primary and secondary coils of the transformer. So these copper wires offer a resistance, and the resistance of these wires will lead to copper losses. So if you are using a thicker wire, the thicker wire has less resistance compared to thin wire. So if you are using a thicker wire, the amount of copper loss can be reduced. Because of this, we are using primary coil because of this, we are using thick copper wire as a primary coil. The second one is eddy current losses. Now what is eddy current? Eddy current means here in the transformer we are applying an alternating current in the primary coil. This alternating current will generate a swirling current in the coil. Swirling current means changing current, or swirling means completely changing current. So this swirling current is known as the eddy current. Now this eddy current will lead to production of heat in the core, and because of this eddy currents, there is power loss in the transformer. These eddy currents, it can be used or it can be reduced by two methods. The first method is you can use a laminated core where the total path for eddy current will be increased. The second method is we can use a high resistance silicon steel as core. That means in place of iron core, we can use a high resistance silicon steel. So these two methods will help us in reducing the eddy current losses. The third one is hysteresis loss. Now hysteresis loss means the alternating current that we are applying, it will induce an alternating magnetic flux which will lead to rearrangement of magnetic dimensions in the core. This repeated rearrangement is known as hysteresis, and this hysteresis will cause a heating of the core, and that will lead to the wastage of electrical power. Now this hysteresis loss can also be reduced by using a laminated silicon steel core. So I'll just repeat once more. Copper loss means it is caused due to the resistance of the copper wire. Now this copper loss can be rectified by using thick copper wires. In place of thin wire, we can use thick wires because the thick wire has less resistance. Second one is eddy current. Eddy current loss. So eddy current means it is a swirling current that is induced in the core as a result of the alternating current applied. This swirling current is known as the eddy current. So this eddy current, what it will do, it will lead to production of heat in the core, thereby reduces the electric power. Now this eddy current, it can be minimized with the help of two methods. The first method is we can use a laminated core. Now the use of laminated core will lead to increase in the path for the eddy current. The second one is in place of iron core, we can use high resistance silicon steel in order to reduce the eddy current losses. Now third one, that is the hysteresis loss. So hysteresis loss is caused due to the alternating magnetic flux that is generated as a result of the alternating current. Now this alternating magnetic flux, it will lead to rearrangement of the magnetic dimensions. This repeated rearrangement is known as hysteresis, and this hysteresis also leads to heating of the core, and that will lead to wastage of electrical power. Same as the eddy current loss, hysteresis loss can also be reduced by using laminated silicon steel core in place of iron core. Now let's discuss about the construction of the transformer. So the construction of the transformer we shall discuss under three topics. The first one is windings. Windings means I said that there are two coils in the transformer. We have got primary coil, we have got secondary coil. Now this primary coil and secondary coil, they are wound around an iron core. Okay, so the primary and secondary windings. So in the transformer, we have got primary windings and the secondary windings. Now these windings, they are wound around an iron core, and the entire arrangement, it is immersed in an oil which helps, which provides cooling action as well as it provides electrical insulation. Now here in this picture you can see the transformer. So here you can see the primary coils. We can also see the secondary coil. Now they are wound on an iron core. So here you can see a square shaped iron core. So an alternating current supply that is applied to the primary side, and the voltage applied across the primary coil, that is Vp. Now as a result of the alternating current, what happens? An alternating magnetic flux will be generated. This magnetic flux will induce an alternating EMF in the secondary coil. So the voltage across the secondary coil, it is indicated by Vs. So from this picture you can see how a transformer looks like. The transformer consists of two windings, primary winding, secondary winding. These windings, they are wound around an iron core, and the entire arrangement, it is immersed in a oil. Now, what are the types of transformers? So we have learned basically two types of transformers, isn't it? Step-up transformer and step-down transformer. So the step-up transformer, it is used to increase the voltage. Step-down transformer is used to decrease the voltage. Now here in X-ray circuit, we will be learning basically two types of transformers, that is autotransformer and high tension transformer. The autotransformer, it can function both as a step-up transformer as well as a step-down transformer, whereas the high tension transformer, it is a step-up transformer. Okay. So here you can see the image of an autotransformer. So here you can see the primary side of the autotransformer, secondary side of the autotransformer. And this is a high tension transformer. This is the picture of a high tension transformer. In high tension transformer, you will find a single primary coil and two secondary coils. In autotransformer, there was only a single winding, and the single windings, they are differentiated into terminals, and it can be used both as primary as well as secondary coils. Now let's discuss detail about the autotransformers as well as the high tension transformers. So this is an autotransformer. So here you can see there is only a single winding wound on a laminated iron core. So this autotransformer, it works on the principle of self-induction. So here you can see this is the primary side of the autotransformer. This is the secondary side of the autotransformer. So here these are the terminals of the primary coil. These are the terminals of the secondary coil. So here you can find that the primary coil and the secondary coil, they have one terminal in common. So this terminal is common for both primary coil as well as the secondary coil. And also they have some number of turns in common. That means from here to here, this is the primary coil. These are the number of turns of the primary coil. From here to here is the secondary coil. These are the number of turns of the secondary coil. So here from this image, it is clear that certain number of turns, they are common for both primary and secondary, and also a terminal is also common for both primary coil and secondary coil. Now, an alternating current is applied in the primary side or the input points. So these are the input points. So the alternating current will be applied between the input points. This will lead to a flow of magnetic flux around the core. So there will be a flow of magnetic flux around the core as a result of the alternating current applied. This magnetic flux will link with all the turns. Okay, so the magnetic flux will be linked with all the turns thereby induces a voltage in each of the turns of the winding. So the induced voltage, it will depend on the number of turns present in the coil. Okay. That means the induced voltage, it will be proportional to the number of turns of the coil. Now here in this auto transformer, we can see that there is no electrical insulation between the primary coil and secondary coil. So these type of transformers, they are used in places where there is there is no need for any electrical isolation between the primary and secondary coil. Now this auto transformer, they are widely used in the X-ray generation circuits. So in the X-ray generator, the auto transformer is used to adjust the voltage applied to the primary of the high voltage transformer with high efficiency and convenience. So this is what an auto transformer is all about. Okay. So once more, I'll just explain in brief. Auto transformer, it has a single winding that is wound around a laminated iron core. So this auto transformer works on the principle of self-induction. Now here, this is the primary side of the auto transformer. This is the secondary side of the auto transformer. So from this image, we can see that one terminal is common for both primary side as well as the secondary side. Also, certain number of turns are also common for both primary side as well as the secondary side. Now what happens here? An alternating current will be applied. So this alternating current will induce a flow of magnetic flux around the core. This magnetic flux will induce a voltage. The induced voltage will depend upon the number of turns. That means the induced voltage will be proportional to the number of turns of the coil. And also there is no electrical insulation between the primary coil and the secondary coil. So these auto transformers, they are used in the X-ray generator circuit in order to provide or in order to adjust the voltage applied to the primary of the high voltage transformer. So we have learned about auto transformer. Now let us learn about the high tension transformer. So the auto transformer, it can be used both as a step-up transformer as well as a step-down transformer. Whereas high tension transformer is a step-up transformer. That means it is used to convert low voltage into high voltage. Now this high tension transformer, it can provide a voltage starting from 20 to 150 kilovolt and a current up to 1000 milliamperes for the X-ray tube. So I'll repeat once more. The high tension transformer, it can provide a voltage ranging from 20 to 150 kilovolt and a current up to 1000 milliamperes for the X-ray tube. So it is a step-up transformer with two windings. So it has got a primary coil. It has also got secondary coils. Now this transformer, it has got a shell type rectangular core. Okay. Now the number of turns in the secondary. So I said that this is a step-up transformer. That means the number of turns in the secondary coil will be more compared to the primary coil. Now the number of turns in the secondary coil, it will depend upon the voltage ratio. So voltage ratio means, for example, if you want to, if you are applying a 400 volt to the primary coil, and if you want to get a say 80,000 volt in the secondary coil, that means here the voltage ratio will be 80,000 divided by 400. Okay, so here you will get 200 as answer. That means in primary coil, if you have one coil, then in secondary coil you should have in primary coil if you have one turn, then in the secondary coil you will have 200 turns. In primary coil, if you have 2 turns, then in secondary coil you will have 400 turns. So the number of turns in the secondary coil will depend upon the voltage ratio. Okay. Now let's see what all are there in the primary coil and how a secondary coil is arranged. Now here the primary coil, it consists of few hundred turns of thick copper wire. Okay, so it is very important. In primary coil you will find thick copper wire. In secondary coil you will find thin copper wire. Okay, so primary coil consists of hundreds, say about 100 turns of thick copper wire, which is well insulated and it is wound on a cylinder. Okay, then a thin copper sheet is fitted over the primary winding, and that is earthed. That means here you will find few hundred turns of thin copper wire which is insulated and it is wound on a cylinder. Now a thin copper sheet will be fitted over the primary winding which will be earthed, and this copper sheet, it is known as the stress shield. Okay, so that is all about primary coil. Now in secondary coil, so secondary coil, here you will find two coils. There are two secondary coils. Now each of the secondary coil will contain about a more number of turns, and these turns will be made up of thin copper wire. So this thin copper wire, it is coated with insulated varnish. So the thin copper wire, it will be coated with varnish. This copper wire is wound on an insulated cylinder which is placed over the primary winding. Now these layers of the secondary coil, they are separated by a thin paper of wax which provides an electrical insulation. So the entire arrangement is placed in a cylinder, in a shell type core. Now here, as I said, we have two secondary coils. So each of the secondary coils, it will be converted to a ammeter which will be earthed. So this is the circuit diagram for a high tension transformer. So high tension transformer has a single primary coil. It has two secondary coils. Now these two secondary coils are connected to an ammeter. This ammeter is earthed. This entire arrangement, it is placed in an insulation oil. Okay, so that means there is an insulating oil in the high tension transformer. Now for those transformers which are used for portable X-ray machines and for dental X-ray equipments, in those equipments you will not find oil in the high tension transformer because only a few amount of heat is generated in these equipments. Okay, that means the high tension transformer used for portable equipments and for dental X-ray equipments, you will not find insulating oil because the heat generation in these equipments are comparatively less. So I'll just brief high tension transformer once more. So the first point is high tension transformer is a step up transformer. That means it will convert low voltage into high voltage. Now this high tension transformer can provide a voltage ranging from 20 to 150 kilovolt and a current up to 1000 milliamperes for the X-ray tube to function. Now here you can find a single primary coil and two secondary coils. So since high tension transformer is a step up transformer, the number of coils in the secondary will be greater than the number of coils in the primary. So these number of turns will depend upon the voltage ratio. So voltage ratio means, I'll explain with the help of an example. If you want to convert 400 voltage into 80,000 volts, your voltage ratio will be 80,000 divided by 400. You will get 200 as the answer. So that means if you have one turn in the primary coil, you should have 200 turns in the secondary coil. If you have two turns in the primary coil, you should have 400 turns in the secondary coil. Now let's discuss what is primary coil, what is secondary coil. So the primary coil, it is made up of few hundred turns of thick copper wire which is insulated and wound on a cylinder. Then a thin copper sheet is fitted over the primary winding which is earthed, and this sheet is known as a stress shield. Now come to secondary coil. It is made up of about 1 lakh turns. So you may find about 1 lakh turns of thin copper wire. It is coated. Now this copper wire is coated with insulating varnish. This entire wire, it is wound on an insulating cylinder. Now between the layers you will find a thin paper of wax which is used as an electrical insulator. Now this entire arrangement is placed in a shell type rectangular core, and also you will find an insulating oil that is filled in order to absorb the excess amount of heat produced in this arrangement. So this is the circuit diagram. You have one primary coil, two secondary coils. The secondary coils are connected to a milliammeter, which is earth. So this is what a high tension transformer is all about. Now the high tension transformer that is used for portable X-ray and for dental X-ray equipments, insulating oils are not used because the heat generation in these equipments are comparatively less. That is why we do not use insulating oil in the case of dental X-ray equipment and portable X-ray equipments. So that was all about high tension transformer. Thank you so much for watching. If you find this video useful, please like, share and subscribe.